When we work with maps, we have to understand the concept of map scale. Map scale is different from the way we use scale in everyday language. Scale on a map means the ratio between the measurement of something on a map and the corresponding measurement of something on the ground. We represent scale in three different ways: verbally, as a graphic, and as a representative fraction. When we talk about large-scale maps, we mean maps that show a relatively small area or small extent, but with a lot of detail. A small-scale map, by contrast, is a map that has a large extent, covers a very large area, but of course has a lot less detail because it's not so zoomed in. This is an example of a relatively large-scale map. It's at 1 to 25,000. You can see that in the lower left. The scale is also represented with a scale bar. But looking at the map itself, you can tell that, or you might recognize this as downtown Boston. Now notice as we change the scale of the map to go to a smaller scale. Now we're looking at not just Boston, but we're beginning to see Cambridge, and we're going to see surrounding areas. Going smaller still, we're zooming out farther, we're seeing the region, we're seeing Boston Harbor. Okay. Notice what's happening to the representative fraction. We've gone from starting off at 1 to 25,000 to 1 to 250,000. Notice also the distance covered represented by the scale bar. Finally, at 1 to 1 million, we're at a much smaller scale. Okay? And smaller scale here is referring mainly to the fact that the representative fraction, the 1 to 1 million, is a smaller fraction, right? Smaller proportion than, say, 1 to 25,000. And I'll go into that in a little bit more detail in a second. So in our representations of scale, when we're working with maps, we have three different ways of representing that scale. The verbal scale means that we describe the scale in these ways, like 1 inch to 1 mile, right? And we're describing, when we say that 1 inch to 1 mile, we're talking about the distance represented on a map and its equivalent distance on the ground. Okay? It can be expressed in any kind of unit of measurement. 1 centimeter to 5 kilometers, for example, is the same basic kind of expression, although they're using different units. A graphic scale, or a bar scale, is probably something you're much more familiar with. So here we have two different styles of graphic scales. The one on the upper one uses both miles and kilometers, two different kinds of measurement units. Miles on the bottom, kilometers on the top. The lower one uses a striped bar, and it's only in miles. And of course, the way that you use these is you can physically use it to measure out distances on a map. The scale bar is probably the most useful type of representation of scale on a printed map, because if you shrink or enlarge the map, say you photocopy it, this will stay true to scale, whereas the representative fraction and the verbal scale may not. And that's something to keep in mind when you produce a map. So you generally want to go with the graphic scale rather than the representative fraction. Now the representative fraction scale can be represented a couple different ways. The one in the center here, 1 to 62,500, is I think in some sense is a truer representation of what we're talking about when we talk about scale. It's also can be represented as a fraction or a proportion. And again, when we're talking about scale, what we're essentially talking about is a comparison between relative distance on the map versus relative distance on the ground. And I'm going to show you an example of how you use that. Okay, so let's look at an example. Let's imagine that we have a particular scale that's shown with the representative fraction of 1 to 2400. Okay. How do we understand this number? Well, the number on the left, the 1, it's always a 1, is the distance on the map. Literally the distance on the map. So if you took out a tape measure or a straight edge, a ruler, and measured 1 inch on the map, what that would mean then is that this distance over here is the equivalent distance on the ground. So it's very simple actually. If you measure out 1 inch on the map, it means that it's 2,400 inches on the ground. If you measure 1 centimeter on the map, it's 2,400 centimeters on the ground. If you measured 1 foot on the map, if you had a map that big, it would measure out 2,400 feet on the ground. So the right-hand side is always, or rather, the map distance you just multiply by the right-hand number, and that's the ground distance. So it's very convenient that way. We say that it's unitless because, again, it doesn't matter whether you're using inches or centimeters or feet. The units always translate the same way. But let's use it in a slightly different way. Let's say that you had the scale and you wanted to know, well, how many feet on the ground is 1 inch, right? That's a little more intuitive, because what is 2,400 inches anyways? So if we wanted to know 1 inch equals how many feet, okay? What we do is we take our map measurement, let's say it's 1 inch, we've measured out 1 inch on the map, and we multiply it by the representative fraction. And the way that we organize it is we put the larger number on top, 2,400 over 1, multiply across, and you're going to end up with 2,400 inches, which you can probably figure out intuitively anyways. But the question is, how do you get this into feet? Well, it's just a matter of converting the inches into feet. So you take your 2,400 inches, and you're going to multiply it by the conversion factor of inches to feet. So we know that in 1 foot there are 12 inches. Okay. So if we cross multiply, then the inches cancel out, and we're going to end up with 2,400 feet over 12. So we just divide 2,400 by 12, and we're going to end up with 200 feet. So 1 inch on the ground, 1 inch on the map is 200 feet on the ground. And you can say that as a verbal statement. That is essentially what you've calculated. Okay. Well, let's look at it in a different way too, because I think one of the things that causes confusion is how to interpret, take the tool back, how to interpret scale in terms of size. So if we were comparing two representative fractions, and let's make them really simple. Let's say that one is 1 to 4 and one is 1 to 10. Okay, so two different scales, two different representative fractions. And the question is, which one is a larger scale? Okay, that's the question. Well, how do we look at that? Well, I told you before that you're essentially looking at fractions, so the question is which one's the larger fraction. But another way to think about it, the way that I kind of try to remember it, is in terms of the pi example. So let's say that we have your favorite type of pie. Isn't very round, but that's the pie. Okay. And somebody asks you, would you like 1/4 of a piece of pie or 1/10 of a piece of pie? So here's 1/4, and here's 1/10. Which one's bigger? Obviously this one is bigger, right? So that's how to think of scale, right? This is a larger fraction than this. This is a larger scale. So just a quick way of thinking about scale in terms of comparing what's larger and what's smaller. Smaller fraction, right? Smaller detail. Larger fraction, larger detail, more zoomed in. So there you go. Large and small scale.